If you have ever sent a text message, you have already interacted with the foundation of modern AI. You type a few words, and right above your keyboard, your phone suggests what you might want to say next. Your phone looks at the last few words you typed and makes a statistical guess. It calculates that when you type, "I will be there in," numbers like 5 or 10 usually follow. The software contains no intelligence or knowledge base. It is merely recognizing a local, mathematical pattern from your past messages and offering the most likely next word. That basic action, guessing the very next piece of a sentence based on the context of the words before it, is the foundational building block for the world's most advanced artificial intelligence. Try a quick thought experiment. What happens if you take that exact same predictive mechanism, but instead of training it on a few text messages, you train it on almost every book, article, and website ever written? These massively scaled-up predictive systems are known officially as large language models, or LLMs. Despite the hype, LLMs are essentially autocorrect on a massive scale, performing the exact same mathematical guesswork at a volume that perfectly mimics human intelligence. When you ask a chatbot a question and it answers in seconds, the seamless experience masks the reality of how it is actually finding that information. A traditional search engine works like a giant filing cabinet. You type in a keyword, and it matches that word to a massive index to pull out a pre-existing static document. A large language model does not store raw facts, files, or pre-written answers anywhere inside its system. It has no database to retrieve from. Because it lacks a database, the system must dynamically invent every response from scratch, creating a unique answer specifically tailored to whatever you just typed. To pull this off, the system breaks language down into small, mathematical chunks called tokens. It does not read words the way a human does. It processes numbers. When you enter a prompt, this diagram shows it passing through a mathematical engine to find the highest probability next word, here, personal. The AI then loops it back into the original prompt, running the entire calculation again to guess the next word. It repeats this loop at lightning speed, guessing one single token at a time. This rapid, sequential looping creates the powerful illusion of a continuous, thoughtful response. A prompt serves as the foundational set of instructions, establishing the starting pattern the AI will follow. If you give the system a weak, generic prompt, it calculates a vague pattern. Highly detailed prompts that define your audience, tone, and specific goal allow the AI to calculate a much more precise and useful pattern. This bounding box illustrates the context window, which acts as the AI's strict short-term memory limit. It dictates exactly how much of your prompt and past conversation the AI can consider when making its next prediction. The AI system only reacts to patterns. Feeding it a tightly constrained instruction set within that context window is the only way to guarantee a highly useful business output. Because these models are absolute masters of mimicking human language patterns, their outputs always sound incredibly confident. This creates the fluency trap. As humans, we have a dangerous tendency to mistake highly articulate, easy-to-read language for verified factual accuracy. If a completely fabricated statement represents the most mathematically likely sequence of words based on a bad prompt, the large language model will confidently generate it anyway. Understanding the autocorrect nature of AI proves why it must never be treated as an autonomous, unverified source of absolute truth in high-stakes work. To get real value, we have to shift our mindset away from asking what the AI knows. Instead, we focus on what it can help human workers create, draft, and summarize. Human oversight, domain expertise, and accountability remain non-negotiable requirements to validate the AI's raw probabilistic output. Success comes from deploying AI to accelerate the first draft of complex knowledge work rather than expecting the software to think independently. By removing the hype and understanding the underlying math, leaders can confidently harness generative AI not as magic, but as a revolutionary tool for enterprise productivity.